Good afternoon, everyone. I'm Jean Cadieux, the chair of the Broadband Data Task Force. I want to thank everyone for joining the webinar and hope that it will be informative and helpful. Our goal today is to spend some time walking through the proposed challenge, verification, and crowdsource methodologies described in the public notice and technical appendix released on July 16th. As directed by the Broadband Data Act, the Commission has adopted user-friendly mobile challenge and crowdsource processes that will enable consumers to submit their challenge data through a speed test app on their mobile device. State, local, and tribal governments and other third-party challengers can also use that same speed test app or submit other on-the-ground test results. But while the method for submitting a challenge is relatively simple, what must go on under the hood the FCC to process those challenges is most definitely not simple. In the third report and order released last January, the Commission delegated to the FCC staff the important task of developing and implementing these complex behind-the-scenes processes. And I want to thank and commend the staff for their tremendous effort to accomplish this difficult task. We believe that the methodologies that they have developed will ensure that challenge data constitute a statistically representative sample of speed tests at a particular geographic area so that they meet an appropriate threshold for requiring a provider response. As directed by the Commission, the staff has proposed a methodology that will resolve challenges in an efficient manner, mitigate the time and expense involved, and assure that mobile coverage maps are as reliable and useful as possible. Today, our speakers will walk through the proposals described in the public notice and technical appendix to help interested stakeholders understand the proposed methodology. While the processing steps that they will describe are quite complex, I want to again emphasize that challengers simply need to take on-the-ground speed tests and submit their results, and that the systems we are implementing will do all of the necessary aggregation behind the scenes. We want to be sure that the methodology we're proposing meets the goals established by the Act and the Commission, and will therefore welcome comments that will help us refine our processes. As a reminder, comments are due on August 27th, and replies are due on September 13th. Before we begin, I'd like to run through a few housekeeping matters. First, nothing in the webinar or in the slides supersedes any provision of FCC rules, orders, or public notices. The webinar should not be used as a substitute for reviewing the Commission orders, rules, and public notices regarding the broadband data collection, and the examples presented for illustrative purposes today are based solely on hypothetical speed tests. Second, we will reserve time at the end of the three presentations for questions, so please email any questions to broadbanddatainquiries@fcc.gov. During the Q&A part of the webinar, Jonathan McCormick, Deputy Director of the Rural Broadband Auctions Task Force, will take the lead in responding to questions with the help of other staff. Third, attending or asking questions as a part of this webinar will not require a filing under the Commission's rules governing ex parte communications. But please don't submit questions that contain comments directed to the merits or outcome of the matters raised in the public notice, because those would require an ex parte filing. So now let's turn to the main event. Our first presenter will be Sean Sullivan, an economist in the Office of Economics and Analytics, who will start off by providing some background information on the mobile challenge and verification processes. Sean?
Thanks, Jean. The Broadband Data Act sets out several requirements that are relevant to the mobile challenge process and the mobile verification process. First, the FCC is to collect granular data from broadband internet service providers on the availability and quality of broadband service. The FCC must also establish a challenge process as well as verify the accuracy and reliability of the broadband coverage data that providers submit in their broadband data collection filings. Two other requirements related but not covered in today's presentation are to use crowdsourcing to improve data accuracy and the development of a process to collect verified data from governmental entities which are responsible for mapping or tracking broadband internet service coverage, third parties, or federal agencies. In the second report and order and third further notice, the FCC adopted some of the BDA's requirements for collecting and reporting broadband coverage, developed a framework for the BDC, established a process for verifying broadband data from providers, and adopted a framework for collecting crowdsourced information. In the third report and order, the FCC adopted additional requirements for collecting and verifying provider-submitted data, established the challenge process, and directed the Office of Economics and Analytics, the Wireless Telecommunications Bureau, and the Office of Engineering and Technology to design and develop the new BDC platform for mapping broadband availability and to set forth the specifications and requirements for the mobile challenge, verification, and crowdsourcing processes. In order to verify the accuracy and reliability of the new BDC mobile coverage maps, the FCC will rely upon mobile speed test apps, including the FCC Speed Test app and other approved apps. These apps will measure network performance quality through various metrics such as download and upload speed, latency, and signal strength. In particular, we will use download and upload speed measurements from testers to compare the on-the-ground experience with the predicted minimum download and upload speeds. We acknowledge that many real-world factors, including but not limited to device performance and weather, may affect the results but are not accounted for in the modeling used for the coverage maps, and that testing may not be conducted in an ideally random sample. Therefore, in this proposal, we take steps to create a robust and representative sample of speed tests before assessing the accuracy and reliability of the coverage maps. All speed tests submitted either for the mobile challenge process or mobile verification process would be subject to several validations. More specifically, we would require all tests to be located inside the respective coverage area of the provider. To conform to the most recent data specification for mobile test data, including a complete set of the required fields and where each field has a value in the set or range of acceptable values. For example, speeds must be non-negative values. And to be conducted within the hours of 6 a.m. and 10 p.m. local time. Tests that meet these conditions would remain valid for 1 year from the date the test was conducted. In addition to these validations done by the BDC system when tests are submitted, the proposal requires that parties make several certifications about their tests. Specifically, testers must certify that their handset and speed test app are in ordinary working order, certify that all submitted tests were taken either in in-vehicle, mobile, or stationary environment, and certify that the tester is a customer for challengers or an authorized user for providers of the provider being challenged or verified, both requiring submission of all conducted speed tests in these certifications would help prevent gaming of the system. That is, the risk that we would rely upon a biased sample of measurements to determine challenges. We propose to use a fixed geographic grid system to group speed tests called H3, which is a standardized open-source geospatial indexing system developed by Uber. H3 uses hexagons to divide the surface of the Earth into unique cells. Though H3 has 16 resolutions ranging from 4.25 million square kilometers on average to 0.9 square meters on average, the mobile challenge process and mobile verification process would rely on resolutions 9 through 5, respectively about 0.1 square kilometers to about 253 square kilometers on average. H3 employs a nested cell structure so that a lower resolution hexagon cell contains approximately 7 hexagons on the next highest resolution. In this slide, the left figure shows a resolution 7 hexagon. The center figure shows the same parent resolution 7 hexagon with 7 resolution 8 children hexagons, and the right figure shows 49 resolution 9 hexagons in the original resolution 7 hexagon. You will notice that the child hexagons will not nest perfectly within the parent hexagons, and the parent-child relationships are defined by the centroid of the child hexagons. Before Brian and Ed discuss the details of the mobile challenge and mobile verification processes, I would like to highlight the main similarities and differences between these two proposed processes. First, both of these processes primarily rely upon the on-the-ground speed test to evaluate the accuracy of coverage maps, in addition to infrastructure data in some certain circumstances. Second, all tests used to determine a challenge, rebut a challenge, or verify coverage require validations and certifications. And third, both processes use the H3 system to define geographic areas. However, since the challenge and verification processes serve different goals, there are some important distinctions. First, the mobile challenge process is triggered by on-the-ground speed tests, whereas the mobile verification process is triggered by a verification inquiry by FCC staff. Also, the mobile challenge process is intended to identify relatively small geographic areas where coverage may be an issue and thus require testing by challengers in these small areas. On the other hand, the mobile verification process uses a sampling approach, allowing providers to test only a subset of areas to verify a larger geographic area. Now I will turn it over to Brian to discuss the mobile challenge process.
Thanks, Sean. Hi, I'm Brian, Information Systems, and I'm going to present to you the proposed mobile challenge process. The goal while creating the challenge process was to create a statistically sound process to identify areas with inadequate coverage. To accurately measure the coverage in an area, we propose to require tests to be taken at multiple locations and multiple times. In the examples here, we'll assume the area is entirely within a provider's coverage map. Red points represent negative speed tests, that is, speed tests that did not meet either the minimum upload or download speed requirements. Green points represent positive speed tests, or tests that did meet both the minimum upload and download speed requirements. As we'll discuss in the following slides, when there are a sufficient number of negative tests that satisfy the required geographic and temporal diversity, an area will then be considered challenged. The steps we are going to discuss in the next few slides for aggregating and processing challenger speed tests may seem complex, but we want to reiterate that the system will be doing this work. Challengers just need to focus on taking and submitting speed tests. After each speed test passes the validations, we propose to aggregate it with all other valid submissions to determine potential challenges. Each test would be associated with a resolution 8 hexagon using the location of the test, as determined by the midpoint between the locations of the download and upload tests. We then propose to evaluate each hexagon containing tests to determine if it satisfies 3 thresholds: the geographic threshold, or speed tests taken in different areas within the hexagon; the temporal threshold, or speed tests taken at different times of day; and the numerical threshold, or whether there are sufficient negative tests to question the adequacy of the coverage. The geographic threshold is used to demonstrate that there are sufficient negative tests across a given area. To evaluate the geographic threshold, we plan to use the 7 child resolution 9 hexagons for grouping. We will count the number of child hexagons containing at least 2 tests with at least one of the 2 tests being a negative. If 4 or more child hexagons have this condition, then more than half of the child hexagons have sufficient tests and the geographic threshold is satisfied. If the child hexagons do not contain roads and therefore may be inaccessible or are not part of the provider's coverage, this 4-child hexagon threshold may be reduced. Please refer to the public notice for more details. The temporal threshold is used to demonstrate that negative tests occurred at multiple times of day. To evaluate the temporal threshold, we will look at the time of the testing for all negative speed tests in the hexagon, ignoring the date of the test. 2 negative tests must be taken at least 4 hours apart. If one test is taken at 9 a.m. and another test at 4:30 p.m. on the same day or weeks apart, the threshold would be satisfied. Although all but one of the negative tests could be at the same time, we expect that most challengers will provide more variability in their testing. The testing threshold is used to demonstrate there is a statistical likelihood that there is inadequate coverage in the area. This threshold depends on the number of tests taken. As more tests are submitted, our confidence grows in the test results, and therefore we need a smaller percentage of negative tests to question the coverage. For example, if 50 tests are submitted, at least 20% of the tests must be negative. 20 or fewer tests require 5 negative tests because the testing threshold has already been met for 20 tests, so additional tests are not required to satisfy the testing threshold. In this example, there are 11 total tests, 9 of which are negative, so the testing threshold has been satisfied. Once all 3 thresholds are met, the Resolution 8 hexagon becomes tentatively challenged. If a challenger submits tests in an area and it is not tentatively challenged, they will be informed which thresholds are not satisfied and have the opportunity to submit additional tests. At the end of each month, any hexagon that is tentatively challenged becomes a cognizable challenge. If multiple hexagons are challenged in an area, we propose to use the nesting structure of H3 to create larger challenges. A Resolution 7 hexagon has 7 Resolution 8 child hexagons. If 4 or more child hexagons are challenged, the parent Resolution 7 hexagon will also be challenged. Similarly, if 4 or more Resolution 7 child hexagons are challenged, then the Resolution 6 parent hexagon will also be challenged. If multiple areas are challenged, but not sufficient to trigger a lower resolution challenge, then a provider still may be subject to a verification request for the area, as will be discussed later in this webinar. At the conclusion of each month, a provider would be notified of any hexagons that are cognizably challenged. Additionally, any challenger whose speed test contributed to the challenge would be notified of the challenge. This would begin the 60-day response period for the provider. During this period, the provider can submit evidence to restore an area to its pre-challenge state, or to confirm coverage in the challenged area, or the provider can revise their coverage maps to remove the challenged area. If a provider chooses to rebut the challenge with on-the-ground speed tests, the speed tests will be validated in the same way as they are for challengers. A provider can submit tests in any hexagon that was challenged, or is a child of challenged hexagon for lower resolution challenged hexagons. To successfully rebut the challenge, and demonstrate sufficient coverage in the hexagon, we propose that the provider's speed test must satisfy the same 3 thresholds as challengers, but modified to reflect demonstrating coverage with positive tests. Similar to the geographic threshold for challengers, we propose that there must be at least 2 tests in 4 child resolution 9 hexagons, with at least one of the tests in each of the child resolution 9 hexagons being positive, for the geographic threshold to be satisfied. If this threshold has been reduced for the challenger due to inaccessible or uncovered areas, it will be similarly reduced for the provider. The same temporal threshold is required for providers as is required for challengers. The time of day of 2 positive tests must be separated by at least 4 hours regardless of the day of the test. In this example, 1 positive test occurred at 12:30 p.m. and 1 at 7:30 p.m., a difference of 7 hours, thus the threshold is satisfied. Similar to the testing threshold for challengers, the testing threshold for a provider measures positive tests. As with challengers, the threshold depends on the number of tests. For example, if a provider submitted 40 tests, 84% of the tests must be positive. For 20 or fewer tests, 17 tests must be positive. In our example, there are 20 tests, with 18 of the tests being positive, so the testing threshold is satisfied. We propose that once a provider has submitted on-the-ground speed tests such that they satisfy all 3 thresholds, the hexagon will no longer be considered challenged, as the provider has successfully demonstrated coverage. Any area where the provider has successfully demonstrated coverage will be immune from challenges until the first filing 6 months after the end of the 60-day period. In other words, the area will not be able to be challenged until 2 filings have been submitted since the end of the rebuttal period. For challenges at lower resolutions, providers are still responsible for addressing the challenges at the resolution 8 level. If a provider demonstrates coverage in some of the resolution 8 hexagons, and there are no longer 4 or more challenged child hexagons, then there is no longer a challenge to the lower resolution hexagon. In this example, only 3 challenged child hexagons remain, so the resolution 7 challenge no longer applies. If nothing else were submitted, the provider would be required to remove the 3 challenged hexagons from their coverage map, and 2 hexagons where coverage was demonstrated would be unable to be challenged for the period described previously. In certain circumstances, infrastructure data may also be used by the provider to demonstrate coverage existed where the challenger's speed tests show otherwise. If, for example, the network was undergoing maintenance while the tests were being performed, or there was an unusual event like a parade causing out of the ordinary demand on the network, these tests would not be representative of the normal coverage. In this situation, tests identified as being invalid would be removed from the system, and the challenged hexagons would be reevaluated. Any hexagon that no longer satisfied the 3 thresholds would return to pre-challenge state. Any tests that are still valid would remain and could be used in a future challenge. At the conclusion of the 60-day period, any area that remains challenged must be removed from the provider's coverage map. If a larger area remains challenged, any smaller areas where coverage was demonstrated may remain within the coverage map. At this point, I will return the presentation to Sean to introduce the proposed mobile verification process.
Thanks, Brian. In the third report in order, the Commission determined that staff from the Office of Economics and Analytics and the Wireless Telecommunications Bureau may request and collect verification data from a provider on a case-by-case basis, where staff have a credible basis for verifying the provider's coverage data. In response to a verification request, a provider must submit either infrastructure information or on-the-ground speed tests, or both, within 60 days of the request. A provider has the option of submitting additional data that the provider believes support its reported coverage. If staff determines that additional information is needed to complete the verification inquiry, the provider may be required to provide such additional data. I will now turn things over to Ed Keurig to discuss how the proposed mobile verification process would work.
Hello, my name is Ed Keurig, and I'm a mathematical statistician in the Office of Economics and Analytics at the FCC. Today, I'm going to talk about the proposed mobile verification process. The proposed mobile verification process, or MVP for short, that we will discuss today is focused on the case when the provider subject for verification chooses to submit on-the-ground test data. Under this scenario, the proposed process has the following goals: identifying the locations within the provider's coverage map the provider should conduct on-the-ground testing, determining how many of these locations the provider must visit and conduct on-the-ground speed test measurements, evaluating speed test measurements submitted by the provider to confirm conformance with validity requirements, analyzing the speed test data and calculate relevant statistics from the accepted speed test data, and finally, adjudicating whether the provider has passed or failed verification. The proposed mobile verification process consists of the following steps. First, we would define the area to be verified, or the targeted area, that is, the area within the provider's coverage map where FCC staff has a credible basis to request verification from the provider. On the right here is an example of a targeted area within a hypothetical provider's coverage map in the Northeast, with a land area of approximately 4,100 square kilometers, and which covers 7 counties wholly or partially. Next, we would divide the targeted area into parts called units, each of which is a resolution 8 hexagon in the H3 system, same as the hexagons used in the proposed mobile challenge process as just described by Brian. The list of these hexagons is called the frame. In our example, there are exactly 5,311 such hexagons in the frame. Next, we would divide the frame into drive testable hexagons that contain roads and non-drive testable hexagons that do not contain roads. This is the first stage of dividing the frame into non-overlapping subgroups called strata in a process called stratification. This is done because the proposed MVP uses a stratified random design, one of the most common and easy to implement designs in statistical sampling. In our example, the non-drive testable hexagons, which number 1,332, or about 25% of the frame, are shown here in dark gray. After these steps, we would further stratify the drive testable hexagons into several strata based on similarity with respect to variability in terrain, which is a quantity known to correlate with broadband availability. In our example, we stratify the drive testable hexagons into 5 strata as shown in 5 shades of blue. Lighter shades of blue indicate less terrain variation, and darker shades of blue indicate more terrain variation. We would use the cumulative square root of the frequency method to create the strata. We would then calculate the minimum number of hexagons to select overall, or the sample size, and allocate this number among the several strata. We would calculate the number of hexagons where the provider subject to verification would be required to conduct on-the-ground tests using the formula shown on this slide. This formula uses characteristics of terrain variability in the strata and a chosen variance tolerance. In this example, using a variance of 0.3 leads to a sample size of 164 hexagons. We would next allocate the sample size to the strata using the formula shown on this slide. This calculation amounts to a prorated allocation based on the weighted standard deviation of terrain variability in the strata. The table in this slide shows the allocated number of hexagons per stratum. Next, we would randomly select the allocated number of hexagons independently within the strata based on the allocation. The service provider would then conduct on-the-ground tests in the selected hexagons, and all valid speed test measurement data would be analyzed. On the right is an example of a hexagon selected in the sample where the provider has conducted the required on-the-ground tests. We assume here that all submitted speed tests were valid. As in the mobile challenge process slides earlier, a red point indicates a negative speed test, meaning tests that did not meet either the minimum download or upload speed, while a green point indicates a positive test, meaning tests that met both minimum speeds. For the particular sampled hexagon shown here, the total count of speed test measurements is 9, of which 5 were positive tests. Finally, we would estimate broadband availability for the targeted area and adjudicate whether the verification response would pass or fail based on the calculated estimate. We would calculate an overall estimate of broadband availability in the targeted area using the formula shown on this slide. Based on the valid speed tests submitted by the provider for the selected hexagons, the system would calculate the proportion of positive tests for each stratum. Then, using the stratum weights, the system would calculate an overall estimate for broadband availability in the area. The relevant formulas are shown here on the right. Finally, in order to adjudicate whether the verification response would pass or fail verification, we would calculate the upper limit of a one-sided confidence interval for the estimate of broadband availability, as shown here on the right. If this upper limit is greater than or equal to 0.9, which is the threshold proportion we proposed to consider to delineate broadband availability for the purpose of verifications, the provider would have successfully verified the targeted area. If not, the provider would be required to submit revised coverage maps that reflect the lack of coverage in targeted areas failing verification. This concludes the presentation portion of today's webinar. I will now turn things over to Jonathan McCormack for the Q&A.
Thanks, Ed. Hello, my name is Jonathan McCormick. I'm the Deputy Director of the Rural Broadband Auctions Task Force and an attorney in the Office of Economics and Analytics working on the implementation of the BDC project. We will now take a brief break and return in about 10 minutes for a question and answer session. As a reminder, please submit any questions to broadbanddatainquiries@fcc.gov. Thank you. Welcome back, and thank you for all the folks who have submitted very detailed and interesting questions. We'll take some time now to go through and answer some of the questions that came in to give people a better understanding of the material. We may not get to all questions today, but we will try to address things that are generally applicable. And obviously, if there's anything that you feel we haven't gotten to, this email address, broadbanddatainquiries@fcc.gov, will remain open for people to submit questions. And we would encourage anybody who feels that they still have questions after this to reach out to that email address, and staff will get back to you as we are able. So going through this, we had a couple of questions, and one I wanted to touch on first is sort of why hexagons and why specifically the resolution 8 hexagon. Brian, can you give us a little bit of understanding about the thinking that went on there?
Sure, John. The hexagons are a good tiling shape for the US. First, they're close to circles, so the orientation of the shape doesn't matter too much. Whereas squares and rectangles, the orientation matters significantly. Secondly, the distortion due to the curvature of the Earth is less. So if we were to use squares at different latitudes, they would look much less like squares. And we chose resolution 8 because it is nearly a square kilometer. At that resolution, we believe we are getting the right balance for both challengers and providers, while also getting precise maps. Finer resolutions and providers could have to respond to lots of little challenges everywhere, but a coarser resolution could result in excessive burden on the challenger while not getting precise maps. And I also, there's another question that came in, I believe, about will the FCC make the H3 grids, hexagonal grids available? Those are publicly available right now, and you can access them through a variety of different APIs like Python. So they are publicly available to everyone right now. And so you can get shape files for those hexagons.
Thanks, Brian. Sticking with you, and as we go through some more questions about the challenge process, will users be able to see other tests submitted by other users in the speed test portal for the broadband data collection?
Yes, the valid tests submitted as crowdsourced data or as part of the challenge process will be made public, and users will be able to check areas where they are interested in challenging and determine whether there are existing tests in that area.
And how do you intend to implement the proposal to compare speed tests for a particular technology, say 5G, to the coverage maps for that provider for that technology?
That's a good question. The speed test data from the app will report which technology was used during the test. And the challenge portal will compare tests for a particular technology only against the provider's coverage map for that technology.
And continuing on that vein, we have another question here. Are testers limited to using certain devices when submitting challenge speed tests?
The only limitation is the device must be capable of operating on the technology that the challenger is intending to test. For example, a user cannot test 5G coverage using an older model device that is unable to connect to 5G.
Okay. We have another question here. It's a good one. So in rural areas where there isn't any coverage, how can you take a test? Like, will the app report anything, or will actually log anything? What does it actually log if there's no speed reported because there's no coverage and the test fails? So if there isn't any coverage, there are no speeds. So how does the software recognize that?
Yep. The speed test apps that can be used for the mobile challenge process would report a failed test with speeds of 0 at that location. So it would be able to do that. So where the user attempted to conduct the test and had no signal, you would have a speed of 0 for that location. So then that test could be used as a negative speed test against a provider's coverage maps that report coverage in that location. So as long as the device the user ran the speed test on supports that technology, the tests can then be uploaded the next time the device is connected to a network.
And I assume that's if regardless if it's the FCC speed test app or other speed test apps that would be supported and approved by OET. Is that correct?
I believe so, yes.
Okay, another question here, sort of getting to making sure that the tests are comparable. How will the FCC know whether standard equipment was used and whether the test was done under proper conditions as laid out in the proposal?
Another good question. The speed test app will report all the device data for the device used in the test, and the challenge portal will verify that the test was using the proper equipment. We've taken steps to prevent gaming by requiring the tester to submit the complete metrics of the test, and therefore we can identify potential manipulation of the tests.
And I think also part of the proposal, there's a certification and for entities submitting bulk challenges, the engineers have reviewed it as well. So that's another piece that'll help prevent gaming under these sort of circumstances.
And you have to certify that you did not game the system under penalty of perjury.
Okay, so let's turn our attention to a couple questions that came in about the verification process. So these are going to be questions for you, Ed. So question that came in is, can providers test in hexagons other than the hexagons that the FCC selects as part of that sample?
That's a great question. Thanks, John. So providers must test in the chosen hexagons, but are free to submit any additional tests that they conduct. However, because the theory behind the estimation process relies on the randomness in selecting the sample, speed test measurements taken from unsampled hexagons cannot be considered in the estimation process. And this is true for any statistical sampling and estimation exercise, not just here for the BDC mobile verification process.
Here's another one. So why have you proposed to exclude from the targeted area hexagons that are not accessible by roads?
That's another great question, and I think the providers will like my answer. We have proposed to exclude non-accessible hexagons for convenience to the provider. It is expected that a provider subject to the mobile verification process will prefer to conduct both mobile and stationary on-the-ground tests along accessible roads.
Great. So another question that came in, when an area that has highly varying terrain, for example, maybe the Western United States, require more or fewer tests to verify?
Right. That requires more tests. And that's the reason why we do stratification in sampling situations. We want to create strata that are fairly homogeneous to control the variation.
Great. We also received a question about some of the data that we've analyzed or evaluated. And so I want to emphasize that the examples that were given in the presentation today are hypotheticals, and they're not based upon actual measurements. And so that's really all we can talk about at this time. But obviously, we are continuing to do evaluation, and we would welcome anything as part of the rulemaking that comes in from interested commenters or parties out there who want to submit their own data or their own evaluation of the proposal. Had another question about, is there a location requirement for the test server? So there will be further details given about the specific specifications for the mobile speed test data and the files that will come in, as well as if there's any other requirements about the types of data fields or locations there. But Same thing for OET's process of evaluating the third-party apps that are going to be conducting, that will be accepted as part of this process to be able to submit data for the challenge process. So there'll be some more information about that coming at a later date. But for now, the requirements that are set forth in the public notice are the ones that we're proposing. All right. So let's. So we've received a few other questions that are sort of beyond the scope of today's webinar. But as I said earlier, please feel free to follow up with the team. That email address that we had before, broadbanddatainquiries@fcc.gov, will remain active, and staff should be able to follow up for questions that come in that we can answer. Obviously, these slides, this video, today's webinar would be something that is made available on the website for the broadband data collection. So while I take a look to see if other questions have come in while we've been talking, I'm going to hand it over to Jean to answer one question that we received. So what are the next steps in this process after today's webinar? Jean, I think you're actually still on mute.
I knew I would do that. So as I said at the very outset, we are tasked by Congress to develop a user-friendly challenge process, and we are focused on doing that. But to do that requires a lot of complicated calculations and aggregations behind the scenes at the commission. And we've spent a lot of time, the staff has spent an enormous amount of time over the last couple of months really focused on this question. And we think we've come up with a pretty good solution that enables us to do this as efficiently as we can, and it has and to pull in as much accurate information as we can, and to make our maps as precise as we can possibly make them. But we want your help. So comments are due, obviously, at the end of this month, August 27th. Replies are due on the 13th of September. And we really are hoping to get a robust set of comments. This process can only improve by everyone's participation. This is sort of a crowdsourced comment period, if you will. We've set out a lot of information in the public notices, and given how important this is, that we get this right, and the challenge process is an important part of the entire broadband data collection effort. We can collect data from carriers, but it's important that we be able to use a challenge process to really verify and make that data as correct as we can possibly make it. So we want to get this process right. And obviously, it will start once we collect the data. That'll be the sort of the timing for when the challenge and verification processes start. We obviously have to make the data public in order for challengers to be able to assess it and to determine whether or not they need to test it and challenge it. In the meantime, while we're doing this comment period, we're also hard at work on building the systems for the challenge process. It's not a simple IT platform that's going to be developed. It has to take into account massive amounts of data and make it all work together and validate it, and the challenge process work. So we're working on that. We've already hired a contractor who's hard at work on that development now and is moving along, very well. And so we're real pleased with that. So those are kind of the things that we're most focused on with respect to the challenge process. We got a lot of other things going on. We're only talking today about the mobile side of things. We're not talking about fixed, and there's a lot of things we've got to work on with the fabric and other things. We do have responses to an RFP on the fabric, and are busy evaluating those right now so that we can get that part of the project moving. But this is obviously focused on the challenge process. And again, we will welcome your comments on August 27th.
Thanks, Jean. So we do have a couple more questions that we wanted to get to that came in at the end. And of course, as we were saying before, if you have questions after this, feel free to email that email address, broadbanddatainquiries@fcc.gov, and be in touch if something comes to mind after this. So Brian, this question is probably for you. We received a question that was asking about how we came to the temporal diversity requirements. Do we have data that shows that there's an impact of time of day on tests? Can you speak a little bit to that?
Yeah, sure. So when we were developing the mobile challenge process, we looked at FCC data from multiple previous efforts, and we did see that there is some temporal variability in coverage. So we wanted to make sure that poor coverage was consistent when there was a challenge, and good coverage was consistent for verification and rebuttal, and that this wasn't just isolated good coverage or bad coverage at a single time period.
Great, thank you. So we did receive also another couple questions that I think I can probably handle myself. So Brian had already touched upon that the H3 shapefiles, the H3 API is available publicly. I believe there may even be some GIS data out there that maybe even in shapefile format. But the question is, will the FCC provide easier access for these shapefiles? And that's certainly something we can take back and consider doing. Obviously, the broadband data collection public map, in order to facilitate this whole process, and in particular to help facilitate allowing for a user-friendly challenge process. We are, as Jean said, hard at work on the IT development for these complicated systems, but we can certainly do, certainly try to make available any data files that would be helpful for people on the outside to either evaluate these or understand and run their own analyses based upon the data that comes in. So that's certainly something we can take back. I think certainly for the public version of the map that comes out, that could be something that is able to be accommodated. To the extent that those shapefiles are needed before then, I think we would have to talk internally about in what format we could do. We could make those available, but we can certainly take that back. And so one other question, or a couple of questions I'm sort of synthesizing. There was a question about differences between different handsets, both in terms of the technologies they support and, just the variability in performance that one device, maybe even two devices that are of the same model, might get. It also questions about, what sort of frequency bands that a device must be capable of accessing in order to take advantage of things like carrier aggregation, and asking specifically are consumers or people wanting to participate in the challenge process going to have a list of acceptable handsets that they can use. So the Commission did not adopt a limitation that would have only certain handsets approved as acceptable handsets. That's a bit of that differs a little bit from what the Commission had done in a previous iteration of a challenge process for the universal service context. But obviously, we do understand that there are differences between individual devices. There's differences between different models. And so the point of the challenge process proposal that was put together is to aggregate across different data sets in order to kind of smooth out any variations there, but also to require that these devices and apps report information, the signal strength, signal quality, all those sort of radio frequency metrics on a per carrier basis, on a per cell sector basis. So we are getting a lot of information. We are going to be requiring submission of a lot of information as part of this proposal that will allow for both providers who are facing a challenge to respond meaningfully, but also for us to understand and account for any differences that we see that may look like they're anomalous due to a particular device malfunctioning, and allow for carriers to providers to respond and indicate certain information or certain reasons why we should not rely upon certain measurements because they were not reliable or not indicative of how a test on their network should behave. How a device on their network should behave in that particular time. So that is part of the proposal. That's about all I can say about that at the moment, but obviously we would welcome any further feedback or specific comments that you would have as part of this rulemaking. And if you think that there's any pieces that we're not accounting for or additional restrictions that should go into there, up to and including potentially limiting to certain devices, certainly you can include that as part of your comments as in this rulemaking. So I think that's about all the time that we have for questions, and basically pretty much all of the questions that we were able to answer for the time being. So I don't know, Jean, I'll turn it back over to you to say some closing words. But again, if other questions come in, feel free to reach out to us at that email address.
Great, well, thank you. So thanks everyone for attending. Really appreciate your participation in the webinar, and thank you presenters for your work on this. I hope that it's been helpful to the audience. I think it has. It certainly has been a very clear sort of explanation of a very complicated topic. So again, we look forward to comments August 27th, September 13th. And in the meantime, would be more than happy to address any specific questions you all may have and as you go through the documents. So thanks very much. I think that's the sorry, I had it on mute. Anyway, thank you very much. Appreciate your attendance, and sorry about the interruption. Thanks.